Welcome back, focused learners, to another explainer. I am absolutely thrilled to have you here today because we're looking at something that is literally rewiring the sports we love. Seriously, whether you're watching from the stands or you're out there competing on the pitch, data is the ultimate currency in modern sports right now. But as we're going to see today, raw data doesn't win championships, and it definitely doesn't build fan bases. It's all about translation.
Okay, let's dive into this. Because comparing a devastating ACL tear to a 15-second viral TikTok clip seems totally ridiculous, right? What could they possibly have in common? Well, the answer is artificial intelligence. AI is acting as the great translator in sports today. It's the exact same underlying technological revolution, decoding both the on-field protection of an athlete's body and the off-field emotion of the fan's experience. It's wild. To really wrap our heads around this, we're taking a full 360-degree journey today. We're going to cover 1, the AI sports revolution, 2, stopping injuries before they happen, 3, the deep learning playbook, 4, turning data into emotion, and finally, 5, the future of AI sports. Let's get into it. Part 1, the AI sports revolution, translating raw data. So modern sports generate literal mountains of numbers, right? But those numbers, just sitting there on their own, are completely silent. And this is the core theme I really want you to keep in mind throughout this explainer. Data is everywhere. But whether we're talking about a super subtle physiological drift in an athlete's heart rate variability or an incredibly dense stat sheet handed to a fan watching a broadcast, raw data is essentially useless. AI is the engine converting all that static data into meaningful, actionable narratives. It's the translator.
Which brings us to part 2, stopping injuries before they happen, the athlete's body.
We're diving into the highly academic, high-stakes world of biomechanics and injury prediction here. And this brilliantly illustrates the massive shift we've seen in sports medicine. The old way of preventing injuries relied on subjective gut feelings from coaches, or maybe static snapshots, like a functional movement screen done just once a month. But injuries don't just happen in a vacuum. They happen dynamically over time. So the new way, it relies on continuous data streaming, where AI constantly fuses multiple modes of information to generate real-time predictions as stress and strain evolve during a grueling season. To get that continuous flow of data, athletes are now wearing these incredible arrays of sensors. We've got inertial measurement units, or IMUs, tracking acceleration and joint angles. We've got EMG sensors tracking exact muscle activation. We even have these emerging flexible electronics, like smart textiles that literally stick to the skin to track microvascular fluctuations and muscle tremors. And the crazy part? All of this hardware gathers incredibly varied data simultaneously, without interrupting the actual game at all. But what's really fascinating here is that AI is teaching us injuries aren't just physical. Yes, for sure, we track the kinematic and physiological layers, but crucially, AI now factors in psychophysiological data too. Think about it. High training loads disrupt sleep and elevate stress, which activates the HPA axis in the brain, raising cortisol levels and delaying tissue repair. It's a chain reaction. AI can literally connect an athlete's poor sleep quality on a Tuesday to a ruptured ligament on a Saturday. Just mind-blowing.
All right, part 3, the deep learning playbook, decoding biomechanics.
So now that we have all this amazing hardware gathering the data, we need software to actually make sense of it. Let's move ahead and see how this builds in a real-world scenario, like predicting an ACL tear. Step 1, an athlete jumps, and their IMU variables gather raw kinematic data on their movement. Step 2, a specific type of AI called a bi-LSTM neural network models that complex movement sequence over time. And then step 3, in a split second, the AI detects an abnormal peak in knee valgus, which is that really dangerous inward collapse of the knee, right before stability is actually lost. It's finding a hidden split-second deficit in neuromuscular coordination that the human eye simply cannot see. But what about injuries that build up slowly over months, like stress fractures? Well, for that, we use transformer models. Now, you might know transformers from text AIs like ChatGPT, but in sports, they process multi-week training histories. Because they use what are called attention mechanisms, they're incredible at spotting long-term cumulative fatigue and physiological drift. They can literally look at weeks and weeks of data and highlight the exact window where an athlete hasn't recovered enough and a bone is just about to fracture. Moving right along to part 4, turning data into emotion, the fan's screen. So that's how AI protects the physical body. But let's shift our narrative completely. We're moving from the internal world of the athlete to the external world of the fan's digital screen, where data translation is all about driving emotion. Just look at this huge number, 81%. According to a recent report by StatsPerform, 81% of sports media organizations have increased their use of AI over the past year alone. Why? Because the modern sports fan demands instant answers, constant content, and deep insights across every single platform they use. Niall Hendry, the VP of AI applications at StatsPerform, sums it up perfectly with this quote: "We exist in a race for the eyeballs. It's not enough to do something great for one game. You need to deliver the same experience for every league." And he is absolutely right. Broadcasters and clubs have to produce interactive, data-driven content at a massive scale. If you do something amazing with data visualization for one game, fans immediately expect it for every game, across every league. And honestly, only AI can operate at that sheer speed and scale to monetize sports media effectively. Now, what's really interesting to see here is the business strategy behind all this content. 81% of organizations use AI to generate short-form content. Think quick TikToks or Instagram Reels powered by instant stats. But only 33% note that long-form AI content drives real, tangible revenue. The strategy here is crystal clear. AI-driven short-form content builds quick awareness and hooks the fan, right? But the deep AI-enriched long-form content is what builds true commercial value and stickiness. But here's the catch. You can't just plug a generic language model into a sports broadcast. The AI absolutely must understand the highly specific, nuanced language of sport. Words like carries or rocks in rugby don't mean much in everyday life, but in sports, they're everything. AI needs this deep context to maintain human authenticity. When broadcasters like the BBC use AI to deploy advanced sports-specific statistics, they see a massive increase in fan stickiness and dwell time, because the context is what actually creates the emotion. And that brings us to part 5, the future of AI sports, risks and realities. So we've got AI predicting an athlete's physical breaking point, and AI scaling a fan's emotional engagement. But bringing both sides of this coin together introduces some real hurdles, starting with explainable AI, or XAI. See, a major problem right now is the black box effect. If an AI tells a coach to bench their star player because a transformer model predicts a 90% chance of a stress fracture, that coach is going to ask, why? And if the AI can't explain its reasoning, the coach simply won't trust it. XAI solves this by providing visual dashboards that highlight exactly which physiological markers triggered the warning. It bridges that crucial gap between cold machine logic and human decision-making. We're also moving rapidly toward the era of the digital twin. This is basically the ultimate fusion of the on-field and off-field worlds. Imagine a complete virtual simulation of an athlete, built entirely from their 3D biomechanics and historical physiological data. It's like a video game character of a real person. Coaches can run virtual simulations of training loads to optimize performance and prevent injury in the digital world long before the athlete ever sets foot on the actual grass. So the crucial point is that while the potential is absolutely staggering, the hurdles ahead are very real. First off, we have data heterogeneity, which basically means mixing different brands of sensors can totally confuse and break the AI models. We also still battle that black box algorithmic trust issue we just talked about. Plus, there are massive privacy questions around who actually owns an athlete's highly sensitive biometric data once it's collected. And on the fan side, media companies have to constantly balance achieving this massive algorithmic scale with maintaining genuine human authenticity in their storytelling. Which leaves us with this final, somewhat provocative thought to wrap up our explainer today. We're entering an era where data translation is becoming nearly flawless. But when an AI system can mathematically predict an athlete's exact physical breaking point, while simultaneously using algorithms to manufacture a fan's emotional joy on a screen, who really controls the game? Is it the players, the coaches, or is it the algorithms? It's a fascinating question about the very soul of sports. Thank you so much for joining me today, Focus Learners. Keep asking questions, keep analyzing the data, and I'll catch you in the next explainer.